Hey guys, I wanted to start off today by reviewing what we were talking about at the end of last week, which is generating gametes through the process of meiosis. Hopefully you remember mitosis, that's for making more cells or growing or repairing or whatever. And meiosis is for creating gametes. It's for creating other cells so that we can reproduce. We're going to talk about a few issues that are sort of tied up with reproduction. So hopefully you remember from last week, we formed this thing called a tetrad. And so you have these two homologous chromosomes. These two are homologous chromosomes. They've made copies of themselves. And so these two are sister chromatids. Then we had some recombination happen. And then those things got together, lined up at the metaphase plate, and then they split apart in meiosis 1. If this is all foreign to you, please go check out last week's lectures. Here is kind of what can go wrong with that process of dividing up your chromosomes in order to make gametes. So here we have, these are both showing the entire process. Here's meiosis 1 on the left, here's meiosis 2 on the right. But if you have a non-disjunction in meiosis 1, you're going to wind up with an extra couple of chromosomes in this cell. When this thing divides, then you wind up with extra chromosomes here. Okay, down here in this cell, you wind up with one fewer chromosomes than you should have. And you wind up with the wrong number of chromosomes down here. So a non-disjunction in meiosis 1 is kind of all bad. All of the gametes wind up having problems. Let's look at what happens if we wind up with the non-disjunction, or failure of chromosomes to separate, in meiosis 2. So meiosis 1 went off without a hitch, as it's supposed to happen. But then in meiosis 2, basically what happened is this chromosome, the sister chromatid, didn't separate. These sister chromatids did separate just fine, but these sister chromatids did not separate. And so you wind up with a cell that has one too many chromosomes, one with one too few chromosomes, and two that are just normal. Okay, so what you should be getting from this is non-disjunction is a failure of either homologous chromosomes, as in meiosis 1, or sister chromatids, as in meiosis 2, to separate when we're making gametes. You should also know that the earlier the non-disjunction happens, kind of the worse it is. Because up here, all of these gametes that we generated have the wrong number of chromosomes. Down here, only 2 of them have the wrong number of chromosomes. So the earlier the error, the worse off the process is. So here we have a diagram that shows the correlation of the mother's age with the risk of having a child with Down syndrome. And Down syndrome is trisomy 21. Trisomy meaning 3 chromosome number 21. And basically what's happening here is, it's pretty interesting, but most human females undergo meiosis 1 while they're still in utero. Those eggs are sort of like halfway done while they are still inside of the womb. And then every month after the woman hits puberty, she is going to have one of those eggs undergo meiosis 2 and sort of finish developing. And either that is going to be released from her body during a menstrual cycle, or it's going to become fertilized with a sperm. The thing is, though, as women get older and older, that meiotic process sort of becomes less efficient, and you become more likely to have a child with trisomy 21. Which, by the way, this is not saying that if you are attempting to have a child and you're a little bit older, this is not saying you're guaranteed to have a child with trisomy 21. You are just more likely because of the way that meiotic process works. Okay, so we've talked about potential problems with meiosis, like non-disjunction, leading you to have the wrong number of chromosomes. Now I want to talk about a super cool thing that happens with your genes. So females have 2 X chromosomes. By the way, that's not true of every species, certainly, but human females have 2 X chromosomes. Feline females have 2 X chromosomes. And what happens is very early in your development as a female, one of those X chromosomes gets inactivated, what's called a bar body. But anyway, one of those X chromosomes gets inactivated, and in cats, that is expressed by them having really, really cool color patterns. So because this kitty here has some of its X chromosomes inactivated, it's going to be black. And the other X chromosomes that were not inactivated are going to make it be orange in those areas. It could actually be the reverse, where the X chromosomes that got inactivated make it orange, and the ones that didn't make it black. It not important to the discussion. The point here being is that females with 2 X chromosomes, one of those X chromosomes gets inactivated sort of randomly throughout the cells. And so some of the cells are using 1 X chromosome, other cells are using the other X chromosome. Here is another genetic issue called Criduct, and this is from another aneuploidy. Aneuploidy, write that one down. Aneuploidy means that you have the wrong number of chromosomes. How do you wind up with an aneuploidy? The answer is nondisjunction. Nondisjunction leads to an aneuploidy. There are other things that could lead to aneuploidy, but that's the only one we're going to talk about. So some other chromosomal issues, don't worry about all of this text, but some other chromosomal issues that you can have are things like inversions. And you see here, basically what's happening is this little segment of the chromosome is getting flipped upside down. Okay, this little chromosome is getting flipped. You can also have translocation, where a portion of a chromosome will break off and move, and in this case is actually going to switch place with another segment of a chromosome. But the point being is that piece of DNA is moving to somewhere where it originally wasn't. So along with inversions and translocations, you can also have a duplication. In a duplication, a portion of that DNA is going to get copied too many times. And so you wind up getting more DNA than you had before. So we have inversions, translocations, duplications, and you can also have deletions. And in a deletion, a portion of that chromosome is just not going to get copied. And so what you wind up with is having no genes where you had genes before. It's just a net loss of genetic information.